Okay, Andrew, so I have the setup as explained, this one, the model that is rounded here. So I'm gonna show you what is the issue that I'm facing. So let's load the model. This one is quite similar to what we have there in the setup. So this is the model. It's loaded. Okay, it's the one that is rounded here, right? Yeah, it's rounded. Yeah. So now I'm gonna run and calculate all the slices according to this setup. That is a slice cut 100 microns. Rotational speed 397 rads per second, and feed rate 100 microns as well. So let's calculate it. Let's wait for some minutes while it's calculating all points. Okay, so it finished already the calculation. Now I'm gonna show you what is the issue here. So if you see the last slice here at the tip of the root, it doesn't have this coordinate, right? So first, second, third, fourth, and then the fifth it has. Then no, and you start having again back. No coordinates, then back, no coordinates, back, no coordinates, back, and then from here through all till the end, it has the coordinates. So that's why for those points without coordinates, there is a misalignment. So when I calculate the intersection point, there is a misalignment between the points, right? So for X, Y, Z, and the angle, right? So even though I'm gonna demonstrate you that you can print when you do the generated G code, that is the one that is printing from the bottom to the tip of the tool, right? So let's generate the G code here. It takes us a few seconds to generate that. So now this is generated here, right? So we're gonna print, taking into consideration this slice, that this is the shape. So we're gonna double check that this is the right shape. Yes, that is the right shape. So let's start the print. So we're gonna send the G code. So now it's moving to this point. Now it touched the point. We can change to rotation. So now this is extruding material. There are some bubbles at the beginning, that's why I didn't extrude material. Now it's extruded. Maybe the pressure was not enough. So do the limitation that is on this axis, you see, it is the plus minus 64 millimeters. So in total 100, yeah, so that is the max distance from this axis. This is not possible to print all the way through all this shape, so it will print more or less until here, more or less 12 millimeters. Yeah. So you see the line. The line is beside the other one, right? So this line that is printing beside the other one that was previously printed. Maybe the pressure is too high. I need to calibrate the pressure a little bit. You can visualize the print from here as well. So let's start the camera. Start the camera here. So sorry, it is me. Change the camera. It's me again. Let's change the camera. Yeah, so this is the print. Now it's going. Yeah, so let's go back to the real print here. Yeah, definitely the pressure is too high. So that is the thing. Now we're gonna send the other print that is going from this point, from the tip of it. Okay, so I finished the print. So from this point, start doing a line because it's not rotating anymore, as I explained. So yeah, it was the print. So too much material here, but it was printing all the shape. So now we need to calibrate this according to the inverse print. So let's see, it's according to the camera. It's this position, more or less this position. Let me see, more or less that way. Yeah, something like this. Yeah, so let's double check that position for the starting point. So this is the image that we need to have as a reference. So this is the last, it says slice at 43.5. This is the last point, 43.5. That should be the position, this position here of the tip of the root. So this is the tip of the root, that position. Yeah, so this is the angle that we need to guarantee here, and this is what we can see from the camera, right? So it's more or less the same. So that is the calibration. Now we can send the inverted G-code. Let's see, inverted G-code. So it was generated here, and now send the inverted G-code. So let's send. So now it's sending all the code. Now we see here it's going to start the print from this point, but as I said, the misalignment will avoid the print to go well. So now we change to rotation. We'll see. Of course, it doesn't have the right point, so it won't print well the first 3 millimeters from here, from the tip to this point, right? So now it's releasing material to the air because there is no contact to the surface. Of course, the pressure is too high, as I said. Doesn't make sense that we keep printing, because first the pressure is too high, and second, it's not following the surface, as the first 3 millimeters are out of the surface. Let's wait a little bit, please. You need to adjust the pressure, but the issue is that as it is no contacting the point, that it is quite difficult to guarantee that this is the right point and remove the pressure. Yeah, so when printing from that point towards the other, then there is no, as it is printing, most of those points are printed on the air, as I said, then there is no point to print. So more or less from that point, this is when it should start printing. Well, of course there is a lot of pressure. But now it's printing on top of the surface. So the first 3 millimeters are a waste of material, as you see all the material falling, because there is no finding a surface. And to allow that, I will need to bring movement to the y-axis, to this axis, but the axis is used here. So that's the thing. And now it's following the surface, more or less. Of course, there are many missed points. There are many points that are missed, and the helix algorithm is not taken into account. So that's why the system goes to whenever he wants to go. I mean, not whenever, because I made some default points just to avoid the clashing. But yeah, this is the thing. This is, and in the bottleneck there, because I don't have the way how to solve this without assistance. So from the previous version that I have shared with you, as it was an axial symmetric model, it was possible to print on top of the surface, but as it is no axissimetrical model, then it's printing on the air at some points, not all points, at some points. Of course, as this is a misalignment of points since the beginning, then it won't synchronize with the movement. So this is the issue, and this is why I need a support from AI tools to solve this and see how I can solve that. Okay, so this is here is almost finishing all the possible area that can be printed until it stops. So it already stops. So as I said, this is more or less measure from here. It'll be easier to measure. So this is more or less. Let me measure from here so it will be easier. So more or less 12 millimeters, and here as well 12 millimeters that can be printed. Yeah, so now it's printing only the 9 because this is not rotating anymore due to the limitation of the X. But that's it. So now you see we printed both sides. This side was well, and the other, of course, no. The first part, of course, it was to hide the pressure, but as well, it was not enough synchronization at this point. So that's it. That's all.